Resistance of a system of resistors. In the previous video you might have seen about the resistance. Now we will be seeing about how the resistors are connected, in the topic resistance of a system of resistors. Two or more resistors can be connected with each other by means of different combinational methods, in order to achieve the desired equivalent resistance in a particular circuit. So let's see the two main methods of joining the resistors together. They are resistors in series and resistors in parallel. We can also mix these two connections and make it as resistance in series parallel connection. First let's see the resistors connected in series. In a series circuit, the resistors are connected one after the other in the form of a single loop. The same current passes through each of them. So when two or more resistors are connected from one end to the other end, then they are said to be connected in series. Just see the above figure about the resistors connected in series. An applied potential V produces current I and the resistors Ri, R2 and R3, causing a potential drop Vi, V2 and V3, through each resistor. Hence, the total potential V, equaled V1 plus V2 plus V3. But by Ohm's law, we know that V1 equal IR1, V2 equal IR2, and V3 equal IR3. Substituting this Ohm's law in the total potential, we get V equal V1 plus V2 plus V3 equal IR1 plus IR2 plus IR3. Since current I is common to all resistors, take I outside of the bracket and write I of R1 plus R2 plus R3. Hence, IR equal I of R1 plus R2 plus R3. Current I on both sides gets cancelled. Therefore, Ramir equal R1 plus R2 plus R3. Here you can see some important points regarding series combination of resistors. First point, an equivalent resistance is equal to the sum of all the individual resistances. Second point, the current through all the resistors is same. Third point, the potential differences across each resistor is different. Now let's see some disadvantages of the series circuit. First point, in the series circuit, if any of the component fails to work, then the entire circuit will break and none of the components will work. Second point, it is not possible to connect a bulb and a heater in series, because they need different values of current to operate properly. So these are some drawbacks in the series connection. Now let's see about the resistors connected in parallel. When two or more resistors are connected simultaneously between 2 points, then they are said to be connected in parallel combination. The electric current divides itself through the different branches. The following figure shows the connection of resistors in parallel. The voltage drops across each resistor will be equal, in the similar way of the resistors in series. According to the Ohm's law, electric current I equal V divided by R, where V is the potential drop, and R is the resistance. Now according to Kirchhoff's junction rule, summation of all incoming current equals summation of all outgoing current. Therefore the total current I is equal to I1 plus I2 plus I3. So 5 divided by R equal V divided by R1 plus V divided by R2 plus V divided by R3. Since voltage V is common on right hand side, take it outside, so V divided by R equal V of 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Cancel both sides voltage, then 1 divided by R equal 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. To conclude, we will see some important points regarding parallel resistors in a circuit. First point, the reciprocal of total resistance is equal to the sum of the reciprocal of individual resistances. Second point, the total resistance is less than the resistance of either resistance, which is known as minimum effective resistance. Third point, the current from the source is greater than the current through the resistor. Last point, the potential difference across each individual resistor is same. Hope you might have got a basic understanding on this topic: resistors connected in series and parallel. Watch one or more times the same video if you are not familiar in the first attempt. So stay tuned for the next topic soon. Till then, goodbye. Have a nice day. Thank you.